we've talked about rational expressions, and now we're going to talk about multiplying and dividing rational expressions. And when we multiply or divide rational expressions, we do the same thing we do with them as we did with multiplying or dividing fractions. And what that is that in multiplying, we take the numerator times the numerator, the denominator times the denominator. So if I have a over b times c over d, I'm going to come up with a times c over b times d. Now notice, I do have to put this restriction in that b cannot equal 0 or d cannot equal 0. Because if they did, when I multiply those out, I'd come up with a 0 in the denominator, which we can't have, all right? When we divide rational expressions, a over b divided by c over d, we change that to multiplication by taking the inverse of c over d. So it becomes a over b times d over c, and then we multiply a times d and b times c. Now, here we have a c in the denominator, here we have a d in the denominator, here we have a b in the denominator. Again, since at one point in time all three of those things are going to be in the denominator, they cannot equal 0. Okay, b cannot equal 0, c cannot equal 0, or d cannot equal 0. Because if I did, that would mean I'd have a 0 in the denominator, which does not make any sense. So let's do this. We're going to multiply 5xy squared over 3y times 4xy over 10xy. All right. Now, this is all multiplication. I could multiply this out for us, all right? So that this would become 20 x times x is x squared, y to the third, over 3 times 10 is 30, x, y to the second. Now, if we find common factors, 20 and 30 have a common factor of 10, so these are going to divide out, and I'm going to be left with a 2 over 3, okay? 20 divided by 10 is 2, 30 divided by 10 is 3. I have an x squared and x. There's a common factor of x, so this is going to go away, and this is going to be x squared divided by x is going to be an x. And I have a y to the third and y squared. Again, I can divide y squared out of both of these, and this is going to leave me with a y on the top. So when I simplify this, this becomes 2xy over 3. All right? Now, the other thing I can do here is, since it's all multiplication, we can start looking for like terms and getting rid of them. All right? So if I have a 5 and a 10, I know that these could divide. 5 divided by 5 is 5, and 10 divided by 5 leaves me with a 2. And I have a 4 and a 2 now, and 4 divided by 2, this is going to go away, and this is going to be leaving me with a 2. And I have an x and an x over here, so let's get rid of that x. And I have a y and a y, that's y squared, so let's get rid of this y squared here. And this becomes 2xy divided by 3, which is what I think we had before. Now remember, I can do this because it's all multiplication. Okay, I'm taking this times this times this times this times this times this. When I can do that, I can factor out those like terms. Okay, once it's all multiplication. All right. Now if I had 2a squared b over 5b to the third divided by 8a over 20b squared. Again, 2a squared b over 5b to the third times 20b squared over 8a. Okay. Now again, going back to this whole process, b can't equal 0 here, b can't equal 0 here, and now a can't equal 0. So those are some restrictions I had, which I didn't do last time. If I were to multiply this out, this would become 40 a squared b to the third all over 5 times 8 is 40 a b to the third. Well, the 40s are going to divide out. The b to the thirds are going to divide out. I have an a squared divided by a, and that's going to leave me with an a on the top. So my answer is just going to be a. All right. Now, the other thing, like we did before, since it's all multiplication again, I can take at like terms and get rid of them, right? So 2 goes into 8, and I'm left with a 4. 5 goes into 20, and I'm left with a 4. All these 4s are going to divide out now, right? I have a b to the third, so I got a b and a b squared. Those go away. And I have an a, and the a squared leaves me with an a, so I'm left with just an a for my answer, just like we had before. Now, in this case, if I have 2x plus 7 times over 3x plus 1 times x minus 4 over 2x plus 7, again, when I multiply this out, this just becomes 2x plus 7 times x minus 4 all over 3x plus 1 times 2x plus 7. Now, in this situation, since we're multiplying this times this and this times this, if there's anything common here, I can get rid of them. And there is. There's a 2x plus 7 here and a 2x plus 7 there. And that leaves it with an x minus 4 over a 3x plus 1. Now notice, there's no multiplication involved here, so I cannot simplify this any further than what I have right here. All right? Now, going back to here, x cannot equal a negative 1/3 here because that would give me a negative 1/3 times 3 give me a negative 1 plus 1 would be 0. And it can't be a negative 7/2 here because 2 times negative 7/2 is going to be a negative 7 plus 7 will give me a 0. So those are my restrictions, but here's the answer simplified. Okay? 12x minus 20 over 5x times 6 over 9x minus 15. In a situation like this, now we're going to have to start factoring this. If I look at 12x minus 20, I know there's a common factor here of 4 in that. So I can take a 4 out of that, and that's going to leave me with a 3x minus 5. And then I have a times 6, and that's going to be on the top. And then on the bottom, I have a 5x, and I can take a 3 out of this, I believe. So that's going to be 5x times 3 times 3x minus 5, right? Now it's all multiplication. And I have a common factor here of 3x minus 5. So I can get rid of those two. And I can take this 3, and it goes into 6 and leaves me with a 2. There's nothing else I can do here, so I'm left with 4 times 2, which is 8 over 5x. Now, going back to my original equation, x cannot equal 0. And in this case, x cannot equal a positive 5/3. If there's 5/3, it'd be 45 over 3, which is going to give me a 15. And 15 minus 15 is 0. So my restrictions here is x cannot equal 0 or a 5/3. A squared minus 1 over 4a times 2. Again, I'm looking to factor. All right? A squared minus 1 is a difference of 2 squares, so this is going to be a plus 1 times a minus 1 times 2 all over 4a times 1 minus a. All right? Now, just like yesterday, we have this right here. I have an a, positive a here, negative a here, negative 1 here, positive 1 here. If I factor a negative 1 out of one of these, I can get rid of that factor. So I'm going to factor a negative 1 out of the bottom. So I'm going to rewrite this as a plus 1 times a minus 1 times 2 all over negative 4a times, because I'm taking a negative 1 out, a minus 1. Okay? If I multiplied a minus 1 by a negative 1, I'd come up with 1 minus a. So it is the same thing. So these are now going to divide out. And the 4 here is going to divide out with this, so I'm left with a 2. So what I have left here is an a plus 1 over a negative 2. Or I could write this as a negative a plus 1 over 2. Or the other way I could write this is a negative a plus 1 divided by 2. Any one of those three answers would be okay in the simplification of this. What's my restrictions? A cannot equal 0. And 1 minus a cannot equal 0, so a cannot equal 1. So those are restrictions for this particular problem. Now, in this situation, we want to factor. Okay, two numbers that multiply together equal negative 12, add together and equal negative 4. I believe that's going to be x minus 4 times x plus 3. Bad x there. All right? And this is going to be times x squared minus x minus 30. That's going to be two numbers multiplied together. Negative 30, add together to equal negative 1. So that's going to be an x minus 6 times x plus 5. On the bottom, negative 8 and negative 2. So it's going to be x minus, x minus 4, x plus 2. And this is going to be an x minus 6 times an x plus 3. Now, if I look at this, we're factoring. We have 4 factors. 1, 2, 3, 4. 1, 2, 3, 4 on the bottom. I'm looking for like terms. And I got an x minus 4 and an x minus 4. Those can go away. An x minus 6 and an x minus 6. Those can go away. An x plus 3 and an x plus 3. Those can go away. So that leaves me with an x plus 5 over on x plus 2. All right. What are my restrictions? X cannot equal 4, -2, 6, or -3. This is my simplified form. These are my restrictions. Even though at the end I only have this x plus 2, I have to still consider what I had up to begin when I started. X plus 3x plus 2 over x squared plus x minus 6 divided by x squared plus 3x plus 2 over x squared plus 7x plus 12. Let's factor. So this is going to give me an x plus 2 times an x plus 1 over, and this is going to be giving me an x plus 3 times an x minus 2. I believe that's going to work. -6, +1, right? Now I got to flip this. So this is going to go on the top, and this is going to go on the bottom. Okay? So this becomes an, on the top I'm going to have an x plus 4 times an x plus 3. And on the bottom I'm going to have the same thing as I have over here, x plus 2 times x plus 1. Now if I look at like terms, okay, again, here's my, let's do this first. What can x equal? X can equal a -3, or a +2, or a -2, or a -1. And then we have to also consider this here because this was at the bottom to begin with, and so that's going to be a -4 and a -3 again. So we got that -3 twice, so we can just get rid of that. So those are my restrictions. Now, let's look for terms to get rid of. I can get rid of the x plus 2 and the x plus 2, the x plus 1 and the x plus 1, the x plus 3 and the x plus 3, and I'm left with an x plus 4 over an x minus 2. Okay? So that's the idea with simplifying radical expressions once we multiply and divide them. Again, we have to look to factor, and we have to look and see if we can get some like terms.